Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, SET exam, Jest, TIFR, IIT-Jam exam and other exams related to physical science. So this is the lecture number 10 of quantum mechanics. Uh, and before starting the class, I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my lectures which are free of charges and going to help you to crack the exams related to physical science. Okay, so yesterday we were studying particle in uh, one dimensional infinite box, right? And but unfortunately the class was disconnected automatically because of technical glitch. Okay, and that time I was drawing the graph for psi and mod square psi. Okay, so I'm going to start from there. Okay, so I'll start now. Okay, so we were studying particle in 1D. Okay, particle in one dimensional infinite square well potential. Square well potential. Okay, this we were studying, and I have derived the energy for this, and that was n square pi square x dot square, and this is for the potential which is asymmetric potential. Okay, which I have already discussed in my last lecture. You can watch that lecture. Okay, so this is 2 ma square, and also I have derived the wave function, that is root 2 upon L sine n pi x upon a, right? That's what I have derived yesterday in last lecture. Okay, and then I have derived the degeneracy, the energy for first ground state, first excited state, and second excited state, and third excited state, so on. That's what I have already discussed in the last lecture. And then I was drawing the graph for wave function psi and the mod square of psi. That time the class was disconnected automatically, right? So okay, so this we have already done. Okay, so and the potential was asymmetric potential. Okay, potential is defined like this. This is defined zero when x is between 0 to a. Okay, and otherwise it would infinite otherwise, as we have already discussed. Okay, so now I'm going to draw a graph for the wave function. Okay, these are straight lines, guys. Okay, x equal to 0 and x equal to a. Okay, okay, this is the maximum value. a by 2, x equal to a by 2, okay. And then this one, and okay, this was the graph that is for wave function. These are nodes, okay. One node, two node. This is n equal to 1, n equal to 2, n equal to 3, and this is for psi n x, okay. This is the graph. Now we'll draw this node for this one. Okay, this is for sin x mod of sin x psi x square, okay. This is x equal to 0 and x equal to 1. Watch my previous lecture, guys, okay, that I have already explained the wave function and the energy. This one, this one, this n equal to 1, n equal to 2, and n equal to 3, okay. And so this is like this. This one, this is for mod square psi n x, okay. And this is for just wave function psi n x, okay. This was the this one. And also in quantum mechanics, the probability of finding particle will be maximum at x equal to a by 2, okay. From the graph it's clear, okay. X equal to a by 2, okay. And then the probability will be different at different value of x, okay. So this is this is for psi x and mod square of psi n x, okay. This is for psi n x, and this is for mod square of psi n x, okay. And this graph for when particle is in one-dimensional, infinite one-dimensional square well potential, okay. This is the one. So now we are going to study particle in 2D infinite potential box, okay. So let me just check, is my internet working fine? It is working. Okay, so now we are studying particle in two-dimensional infinite well. This is particle in two-dimensional infinite square well potential, square well potential box. Okay, I'll solve questions related to the topic which I am discussing, then your doubts will get clear. Okay, so now particle in two-dimensional infinite square well potential. Okay, if particle is in 2D infinite square well potential, then what would be the energy of it? Okay, so like this, suppose this is the not going, not able to draw a straight line. Consider this is a straight line, guys. Okay, infinite, infinite. This is A, this is B. Okay, particle is in 2D 2D infinite square well box. Okay, and the potential is defined like Vx y v equal to 0 when uh, x is between 0 to a and y is between 0 to a. Okay, we can say 0 to L actually. L is so here the width is L. Okay, this is and infinite otherwise. Okay, this is the potential which is defined for this. Okay, and now we'll find the energy. So energy is going to be energy of particle in 2D infinite square well is going to be, this is nx square upon a square, nx square upon a square plus ny square upon b square into pi square h cut square upon 2ma 2m. Okay, upon 2m. This is the one. This is the energy of particle in 2D infinite square well, and if a equal to b, in that case energy is going to be nx square plus ny square, okay, pi square h cut square upon 2ma square. Okay, then energy is going to be this in 2D. Okay, this is the energy. Now we'll find degeneracy. Okay, where nx here, where nx ny are 1 2 3 so on. Okay, the value of nx and ny. So now we'll find the degeneracy. Okay, very important. I'll solve questions related to this as well, then it is going to be more clearer to you. Okay, x nx comma ny, and then state, after that energy I'm going to make a table, okay? And this is degeneracy. Very important table, guys. So for ground state, this is going to be 1 1, okay? And this is going to be ground state, and the energy for ground state going to be 1 1. It is 2, that is 2 pi square h square upon 2 ma square, okay? And degeneracy is 1. The second case, for first excited state, value of nx and ny is going to be 1 2 and 2 comma 1, and this is first excited state. For this, energy is going to be 1 plus 4, that is 5 pi square h square upon 2 ma square, okay? And degeneracy is going to be 2. Now for second excited state, so it is going to be 2 comma 2, okay? So this is second excited state, and the energy is going to be 2 to the 4, 8 pi square h square upon 2 ma square, 8 pi square h square upon 2 ma square, and degeneracy is going to be 1, okay? Now for third excited state, it is going to be 1 comma 3, okay, and 3 comma 1, right? Value of nx is going to be, so this is third excited state, and energy is going to be 10 pi square h square upon 2 ma square, okay? There is some issue, I think. Just give me 1 minute, guys. There is some issue, audio issue, I believe. Okay, so then the degeneracy is going to be 2 here, okay? So these are the degeneracies. For second, degeneracy is 1. For first ground state, degeneracy is 1. For third and first, it is 3, okay? This is for the this is for the, if particle is in 2D infinite square well potential box, okay? Next. Okay, next is particle in 3D infinite square well potential box, okay? 3D infinite square well potential box, okay? When particle in 3D infinite square well potential box, then the energy is going to be nx square upon a square plus ny square upon b square plus nz square upon c square, okay? Pi square h square upon 2m. So this is going to be the energy of particle when it is in 3D infinite square well potential box, or 3D infinite potential box, okay? And if the a equal to b equal to c for the box, infinite square well box, then in that case the energy is going to be nx square plus ny square plus nz square, okay, into pi square h cut square upon 2ma square, okay, 2ma square. This is going to be the energy for if particle is in 3D infinite square well potential box, okay. Well, so now we will find out degeneracy for this energy, okay, when a equal to b equal to c. So we'll make a table again for this. This is going to be nx comma ny comma nz, okay, and then the state. These tables are very important, guys. You will solve many questions, okay. State, and then energy, and then going to be degeneracy, okay. Meanwhile, I'm checking the connection as well, okay. So all right, so for ground state, this is going to be nx, value of nx and ny, nz is going to be 111, okay, and this is for ground state. And energy is going to be from here, right? We'll put n equal to 1 and n equal to nx equal to 1, ny equal to 1, and nz equal to 1. So this value is going to be 1 square, 1 square, 1 square is 3 pi square h cut square upon 2ma square, okay. And degeneracy is 1 for this, for ground state. For first excited state, this is going to be 1 comma 2 1, okay, and it is going to be 1 comma 1 comma 2, and this is going to be 2 comma 1 comma 1, right. The next value is going to be like this, and this is first excited state, and the energy is going to be 1 4 plus 1 means 6 pi square 6 pi square h cut square upon 2ma square. After this, I'll solve the questions which were asked in Jest, IIT-Jam and GATE exam, okay. And CSIR net question I'm not going to solve because there is a separate class which I'm taking every day, that is the PYQs for CSIR net, okay. So you can check all the PYQs of CSIR net physical science, okay. So there's a separate class for CSIR net PYQs. I think I have completed 7 lectures so far, okay. So for this, the degeneracy is going to be 3, right. This is for first excited state. Now for second excited state, it is going to be, we'll take 1 comma 2 comma 2, okay, or it is going to be 2 comma 1, okay, and this is going to be 2 comma 1 2, right. Right, so this is for second. Second excited state, and the energy is going to be 2 to the 4 9 4 4 4 8 9 9 pi square h cut square upon 2ma square, okay, and the degeneracy is going to be 3. Degeneracy is going to be 3, okay. Similarly, for third excited state, it is going to be 3 degeneracy. Okay, that is, I'll write here 1 comma 3 1. The second is going to be 1 comma 1 comma 3, and the third is going to be 3 comma 1 comma 1. These 3 state. Okay, and this is for third excited state, and this is going to be 309 and 11, right? 11 pi square h cut square upon 2 ma square, and degeneracy is 3. Okay, very important. So so we can get question related to find the degeneracy. Okay, well, this is about the if particle is in 3D infinite spiral potential. Okay, so now I'll explain particle in 1D infinite symmetric potential. Okay, so if particle in 1D asymmetric, we have already studied, guys, in last lecture. Okay, so particle in 1D infinite uh, infinite symmetric potential well. Okay, infinite symmetric potential well. If particle is in 1D infinite symmetric potential well. Okay, if it is in symmetric potential well. Symmetric potential well means like this. Okay, I'll make a diagram. This. Okay, this is x equal to 0. This is x equal to a, and this is a by 2. So this is symmetric line. Okay, this is called symmetric potential. Okay, and V is defined as like this. V is defined as 0 when okay, 0 when x is between minus a by 2 a by 2. Here we have made mistake. So this is like minus a by 2, and this is a by 2, and this is 0. Okay, so this is symmetric about 0. This potential is okay, and this is like infinite. This is infinite potential box, symmetric infinite symmetric potential box, and particle is in it. Okay, this is 0. Second is infinite otherwise. Okay, this is the value of V. V is 0 if it is between minus a by if x is between minus a by 2 to a by 2. Infinite otherwise. Okay, if particle is in 1D infinite symmetric potential like this. Okay, in that case energy will be the same, right? We have the energy is going to be same, that is the same as the particle which a particle is in one dimensional asymmetric potential well, that is the same, that is going to be pi square h cut square m square upon 2 ma square. Okay, this is the energy of this particle. Okay, and then wave function, the wave function is going to be different. Okay, the wave function for symmetric potential, the wave function is going to be psi is going to be root 2 upon a cos n pi x upon a. Okay, here n equal to 1, 3, 5 odd numbers. Okay, and symmetric potential means, I'll explain here. Symmetric potential means Vx, symmetric potential means V minus x is going to be Vx. Okay, this is symmetric potential. Okay, so this is this one, and this is for psi minus x equal to psi x. Okay, this is the wave function if psi minus x, if psi is symmetric. Okay, and the second, psi is going to be root 2 upon a sin n pi x upon a. Okay, sin n pi x upon a, and the value of n is going to be 2, 4 odd numbers, so even numbers, 2, 4, 6, so on. Okay, and this is the case when value of psi minus psi x is, wave function is asymmetric, antisymmetric, minus psi x, minus psi x. Okay, psi minus x equal to minus psi x. For this, so wave function for symmetric, if potential is symmetric, okay, in that case energy is going to be the same as the particle is in infinite asymmetric potential well. Okay, that is n square pi square h square upon 2m square. Okay, which I have already derived. And wave functions are, because this is symmetric potential, that is v minus x is going to be vx. It's a symmetric potential. So here in case of this, the wave function, if wave function is symmetric, that is psi minus x equal to psi x, then the wave function is going to be root 2 upon a cos n pi x upon a. The value of n is going to be odd numbers, 1, 3, 5, so on. And if wave function is asymmetric, that is this one. This condition follows this condition, that is psi minus x is going to be minus psi x, then the wave function is going to be root 2 upon a sin n pi x upon a, where n equal to 2, 4, so on. Okay, that is even numbers. Okay, so this is about or we can also say this is a symmetric wave function, this is antisymmetric wave function. Okay, so this is about the wave function and the energy for the particle in 1D infinite symmetric potential well or potential box. Okay, now we are going to solve questions. So we'll solve the question now. First question, this is from question number first. This is question which is asked in IIT-Jam 2010. IIT-Jam 2010, this question is asked. Okay, IIT-Jam 2010. Okay, question I'm going to write. A particle of mass m, a particle of mass m is confined in a two-dimensional in a two-dimensional infinite square well, two-dimensional infinite two-dimensional infinite square well, infinite square well potential, infinite square well potential of a side A of a side A, the energy, the eigenenergy, the eigenenergy, the eigenenergy of the particle, of the particle, of the particle in the given state, in the given state, in the given state is E equal to 25 pi square h cut square upon ma square. The state is options are option number A, four-fold degenerate, four-fold degenerate, four-fold degenerate. Option B is three-fold degenerate, three-fold degenerate, three-fold degenerate. Option C is two-fold degenerate, two-fold degenerate. Option D is non-degenerate, non-degenerate. Okay, so this is the question. Question is a particle of mass m is confined in a two-dimensional infinite square well potential. Okay, so particle is confined in two-dimensional infinite square well potential. Okay, whose side is okay. The energy of the particle is given. The state energy of the particle in this energy of the particle in the given state is, we have been given, that is 25 pi square h cut square upon ma square. Okay, now we need to find out the degeneracy. Okay, degeneracy we need to find out of the state. Okay, so it is four-fold degeneracy there, if that is if it's four-fold degenerate or three-fold degenerate or two-fold degenerate or non-degenerate, or it is non-degenerate. That's what we need to find out. Okay, so we are going to solve it. We're going to solve it. So we know for 2D, if particle is in 2D infinite square well potential, we know the energy, right? I have already explained in earlier. So this is E is going to be for equal side. Okay, this is given. Okay, this is given of side A. Okay, so this is going to be nx square plus ny square pi square h cut square upon 2 ma square. This is going to be energy. Okay, this is going to be energy where nx value and ny value is 1, 2, 3 and so on, right? So here energy is given, right? Energy is given this here energy is given, since E is given 25 pi square h cut square upon ma square. Okay, so this is given. So when we are going to get for what values of nx and ny we are going to get this value, obviously this is clear here in this. So for what value? Okay, so it's clearly seen that for nx equal to 5 and ny equal to 5, we are going to get this value, right? If you put nx equal to 5 and ny equal to 5 here, so it is going to be nx 25 plus 25, that is 50 pi square h cut square upon 2ma square. 2 will cancel the 50 to 25 times, right? So this is going to be 25 pi square upon this, right? Like I'll write here like this: nx 5 square plus 5 square pi square h cut square upon 2ma square 5 5 50, 25 25 50 pi square h cut square upon 2ma square, and this will cancel by 25, right? So this is going to be 25 pi square h cut square upon 2ma square, right? You understood it. So for value of nx equal to 5 and ny equal to 5, we are going to get this value. Which value? This one, this 25 pi square h cut square upon ma square. Very simple question, right? So obviously n equal to 5 and ny and nx equal to 5 on ny equal to 5, right? So degeneracy is 1. Okay, so the degeneracy is there is no degeneracy, okay, right? So which is non-degenerate, right? So implies 5 5, that implies nx and y value is 5 5, that is non-degenerate. Okay, so which option is correct? This one, non-degenerate. Very simple question, non-degenerate. Okay, this one. Okay, so now we are solving next question. This is question number 2. Okay, this is the question which is asking gate. Gate 2012. This question is asked. Okay, this is question number 2, and I'll write it for you. And these are very simple questions, okay, which I have already taught you. These are questions based on what I have taught you earlier. Okay, so this is a particle of mass m. Mass m is confined in a two-dimensional particle is confined in two-dimensional particle is confined in two-dimensional square well potential of dimension of dimension A the potential Vxy is given by Vxy function of Vxy equal to 0 for minus a when x is between minus a to a, okay, and y is between minus a to a, okay, and infinite elsewhere, okay, infinite elsewhere, okay. This is the potential is given, okay. Now the energy of the first excited state of this particle is given by, okay. So the energy of the first excited state energy of the first excited state for this particle is given by, okay. So potential is given, we need to find out energy of the first excited state, okay. Options are given. Option number A, this is pi square h square upon ma square, pi square, okay, I'll write in next page. Wait guys, system got hanged. Okay, options are option number A, pi square h square upon ma square. Option B is 2 pi square h square upon ma square. Option C is 5 pi square h square upon 8 ma square. And option D is 4 pi square h square upon ma square. Okay, these are the options. Very simple question. So we have been given the particle of mass m is confined in two-dimensional square well potential of dimension A, okay. The potential Vxy is given by this, okay. Vxy equal to 0 if x and y are between minus a to a, and infinite otherwise. The energy of the first excited state of this particle is given by, okay. So energy of first excited state we need to find out, okay. So here we know already, I already explained it in earlier, okay, already explained earlier, that is energy of the so understand guys, this is symmetric potential, okay. This is symmetric potential, this is like this. is symmetric potential. This is 0 minus A, okay. This is symmetric potential, guys. So for symmetric potential, energy we know, right? That is for 2D we know nx square plus ny square, because sides are equal, nx square ny square pi square h cut square upon 2ma square, right? This is the energy, 2ma square. Here A is, or I can write for convenience I can write L, okay. L square, L is the length, that width of the potential, right? Width of the potential box. L square, for what is the L given here? Since L is given, the symmetric potential, and for L is here, L is 2a, right? L is 2a, L is 2a here, so we'll put this value. So E is going to be nx square plus ny square into h cut square pi square upon 2m. In place of L square we will write 2a whole square, right? So then this value is going to be nx square plus ny square into pi square h cut square upon 2 to the 4, 4a square into 2, this is 8 ma square, 8 ma square. Now since we know this is for first excited state, you need to find out energy, right? For the first excited state, for first excited state, for first excited state, we know the value of nx is 1 and value of ny is 2, because it's degeneracy for it is 2, right? So nx equal to 1 and y equal to 2, so we'll put the value. So this is going to be nx means this one, nx square plus ny square, okay. So this is going to be 1 square plus 2 square pi square h cut square upon 8 ma square, right? So this is going to be 2 to the 4, 5. So this is going to be 5 pi square h cut square upon 8 ma square, right? This is the answer, 5 pi square h cut square upon 8 ma square. So which option is matching? Let's see, let's check. So option C is matching, right? 5 pi square h cut square upon 8 ma square, 5 pi square h cut square upon 8 ma square. So this is the answer, guys. Very simple, right? That's why I made a table for degeneracy for 1D, 2D and 3D, because you will get questions, okay, in GATE. So this you have already got this question in GATE and just CSIR net, IIT-Jam. So in all the exams related to physical science, you are going to get questions related to this, okay. Okay, so this question is done. Now next question we are going to solve, question number 3rd. Question number 3rd is, this question is asked in Jest, okay. This question is asked in Jest 2013, Just 2013. I'm going to write the question. The question is very good question. A particle of mass m, a particle of mass m, a particle of mass m is confined in a one-dimensional infinite well extending from x equal to minus L by 2 to x equal to plus L by 2. Okay, so yeah, the symmetric potential in 1D. Okay, the particle is in its ground state. The particle is in its ground state. Okay, ground state given by 50x ground state wave function is given. Okay, that is root 2 upon L cos pi x upon L The walls of the box are the walls of the box are moved suddenly from to form a box extending from x equal to minus L to x equal to L. What is the probability that the particle will be in the ground state after this sudden expansion after this sudden expansion. Okay, options are given. Options are number A, 8 upon 3 pi whole square, 8 upon 3 pi whole square. Option B is 0. Option C is 16 upon 3 pi whole square, and option D is 4 by 3 pi whole square. Okay, this is the question. I'll read it for you again. So a particle of mass m, okay, so particle of mass m is confined in one dimensional infinite well, okay, so infinite okay, so particle is confined in one dimensional infinite well extending from minus L by 2 to L by 2, okay, that is the length width of the symmetric potential. Particle is in its ground state given by, okay, so the ground state function for the particle is given psi 0 x equal to root 2 upon L cos pi x upon L. The wall of the box are moved suddenly, so we have moved the wall of box to form a box extending from x equal to L minus L to x equal to L, okay, so uh, we have extended box, okay, minus from minus L to x equal to L. Now so the width of L is going is double to the previous one, okay. Now what we have to find is what is the probability that the particle will be in the ground state after this sudden expansion. Now we have increased the length of wall, right, width of the wall, and now we need to find out the probability of finding particle in the extended box, okay, that's we need to find. Very simple question and very good question, guys, okay. So we are going to solve it now. So this is the case, okay, I'll explain like this. So this is the, I'll explain it like, first condition is like this, okay. This is like, this is 0 and this is minus L by 2 and this is L by 2, okay. Okay, now what we have done is, we have done is we have extended the width of wall, okay, like this became L and this is L and this is 0, so we extended the wall, okay. So now we have to find the probability of finding particle in this box, okay, that is the condition. Okay, so phi 0 is given, for ground state, that is root 2 upon L cos, so it's a even function, okay, that is sorry, that is we call it symmetric wave function, okay. So L, this is given, okay, pi upon L. So we can find phi 1. Phi 1 means after, so wave function of the particle after extending the wall, okay. Now we have extended the length of wall that is twice the previous wall, right, because this was like this one, right, minus L by 2 to L. Now it is we have extended it to L minus L to L, so double we have extended, right. So this is going to be uh, so here the value of L is L, right, and here it is going to be 2L, okay. So the wave function for the extended of the particle which is in extended wall, right, so that is going to be 2 upon, and the value of L is going to be 2L in this case, okay, 2L cos pi x upon L. I hope you understood it, guys, very simple, because we have extended the walls twice the previous one, okay. Okay, so this is the one and this is going to be this 2L, here also it's 2L, okay. Now what we are going to do is we'll find the probability, okay, and we know these are normalized wave function and we know the probability probability that the particle will be in the ground state after this sudden expansion, okay. So the probability formula we know, that is P is going to be mod of phi 0 phi1 whole square, right? This is the one. Now it's a simple integration, we need to do it. Okay, so this is going to be p equal to integration okay, so this is going to be integration minus L by 2 to L by 2. Okay, and we'll put the values 2 upon L into root 2 upon 2L. Okay, root 2 upon 2L, this one, root 2 upon 2L, cos pi x upon a, pi x upon L into cos pi x upon 2L dx, and then outside mod square. This we know, right? This here, because we know this is going to be integration phi 0 phi 1, right? This is phi star, okay, phi 1, and then dx, and limit is going to be minus L by 2 to L by 2, right? This is simple. Okay, now we are going to solve it. So then p is going to be 2 will get cancelled. Okay, and so it is going to be root 2 upon root 2 upon, this is going to be root 2 upon root 2 upon L. Root L is going to be L. Okay, and this we can write into 1 by 2, because this is going to be cos A cos B. We'll multiply by 2 and divide by 2. Okay, so it is going to be 2 cos A cos B, and this is like this. Okay, 2 cos A cos B. We have multiplied by 2 and divide by 2. Okay, so this value we know, cos A plus B by 2, sorry, cos A plus B plus cos A minus B, right? This formula we know. I'll write it clearly so this will be easy for you. This is trigonometric formula. Okay, very simple. Cos A cos B going to be cos A plus B, 2 cos A plus B plus cos A minus B by 2. Like 2 cos A cos B is like this, so 2 will go here. So this is the formula, guys. Okay, we have used here this formula. We have used here. Okay, I'm going to erase it. You understood it, I hope. Okay. So it is going to be so I can write cos integration minus L by 2 minus L by 2 to L by 2. This is going to be cos a plus b, okay, cos pi pi, this is going to be 3 pi x upon 2, 3 pi x upon 2l, okay, and plus cos pi x upon 2l, okay, dx, okay, this is the one, and this is mod square, whole mod square, okay. So we'll solve it further. So it is going to be equal to root 2 upon L, root 2 upon L into 1 by 2, and this is going to be 2L upon 3 pi, okay, we have integrated this, okay, 3 pi, cos is sine 3 pi x upon 2L plus 2L upon pi, okay, sine pi x upon 2L, and limit is going to be minus L by 2 to L by 2 and mod square, okay. Next key is going to be mod root 2 upon L into 1 by 2, this is going to be 2L upon 3 pi, simple integration, guys. We have already studied in class 11th and 12th this integration. So sine 3 pi by 4 plus sine 3 pi by 4 plus 2L upon pi, 2L upon pi sine pi by 4 plus sine pi by 4, okay, mod square. So this is going to be equal to 2 upon 3 pi plus 2 upon pi mod square, okay, and so this is going to be 8 upon 3 pi, 8 upon 3 pi whole square, okay. Which option is matching? Let's see. Option number A is matching, okay. 8 upon 3 pi, 8 upon 3 pi, okay. This is the answer, guys. Let me just check. Okay, so this is a very simple question, okay, and there is only integration, okay, guys. So it is just we have extended the wall, and then we have find the probability of finding particle in that expression, okay. Well, guys, I'm going to stop here, and thank you so much for watching my lecture, and I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my lectures. which are free of charges and are going to help you to crack the exam related to physical science. Okay, so thank you guys. Bye now.